So, why the automotive mechanic is now an automotive technician? If you were to step into an automotive repair shop in the middle of the 20th century, the sensory experience was distinct and undeniable. The air hung heavy with the thick, sweet scent of unburnt gasoline, stale oil, and exhaust fumes. The floor was often darkened by layers of grease and covered in sawdust to soak up the inevitable fluid spills. The soundscape was defined by the rhythmic clanging of heavy steel tools against iron, the roar of carbonated engines being revved to clear their throats, and the shouting of voices over the mechanical din. The person working on the vehicle, the mechanic, was a master of the physical world. They were often covered in grime, wielding impact guns, pry bars, and massive wrenches. They relied on a keen sense of hearing to detect a valve tap, a sensitive nose to smell rich fuel mixture, and an intuitive sense of touch to feel vibration in the chassis. They were tradespeople in the truest sense, manipulating metal, leverage, and physics to keep machines running. Fast forward to a high-quality automotive service center today, and the contrast is stark. The bays are often as clean and organized as a medical laboratory. The lighting is bright, clinical, and precise. While the sound of air tools still punctuates the atmosphere, it is now accompanied by the beep of digital scanners and the hum of diagnostic computers and the clicking of keyboards. The professional leaning over the engine bay is now not just looking for broken parts. They are analyzing a stream of live data on a laptop screen, interpreting voltage waveforms, and navigating complex software algorithms. The shift in terminology from mechanic to technician is not a marketing ploy. It is not an attempt to simply dress up a blue-collar trade with a fancier title. It represents a fundamental transformation in the nature of the automobile itself. As vehicles have evolved from purely mechanical machines into sophisticated computer networks on wheels, the professionals who maintain them had to evolve from skilled trade people to highly educated, tech-savvy expert. The era of the mechanic, a world of iron and physics. To truly understand why the title was changed, we must first appreciate what the job used to be. For the first 70 or 80 years of the automotive history, the car was a triumph of mechanical engineer. It was a world defined by physics, chemistry, and raw materials. In the days of carburetors and distributors, the relationship between the driver's foot and the engine was entire physical. When a driver pressed the accelerator pedal, they were pulling a steel cable. That cable ran through the firewall and physically opened a butterfly valve in the carburetor, allowing air to rush in. The fuel was not injected by a computer, it was sucked in by a vacuum created by the descending pistons and pulled through tiny brass jets. The ignition timing, the precise moment that the spark plug fired was controlled by a distributor, a mechanical device that spun off the camshaft, using centrifugal weights and vacuum diaphragms to advance the spark. Repairing these vehicles was a tactile art form. A mechanic needed mechanical aptitude. They needed to be able to visualize how gears meshed inside a transmission casing. They needed to understand fluid dynamics to properly bleed a brake system. If a car wasn't running right, the diagnosis was often sensory. A skilled mechanic could smell if an engine was running rich, burning too much gas. They could hear the specific rhythmic tapping of a valve that needed adjustment. They could feel a misalignment through the seat of their pants while driving. The complexity of the job lay in the assembly, the fitment, and the physical manipulation of metal. A great mechanic was a craftsman who could rebuild a starter motor on a workbench, machine a brake drum, or tune an engine by ear. While this required immense skill and experience, the scope of knowledge was largely confined to the mechanical realm. There were no lines of code to read. There was no sensors sending voltage signals to a central brain. The car was a machine, and the person who fixed it was a mechanic. Enter the digital revolution, the birth of the technician. So the transition began in the late 1970s and accelerated through the 80s. and 90s. As government regulations regarding emissions and fuel economy became stricter, mechanical systems simply hit a ceiling. A carburetor, no matter how perfectly tuned, could not adjust the fuel mixture fast enough to meet clean air standards and couldn't compensate for the changes in the altitude, the temperature, or the engine load constantly. The solution was the computer. The introduction of the electronic control unit, ECU, changed everything. Suddenly, the gas pedal wasn't just pulling a cable. A modern drive-by-wire system it sends an electrical signal to the computer, which then processes that request and decides how much to open the throttle based on data from a dozen different variables. This was the tipping point. The moment a car began thinking and making decisions based on data inputs. A person repairing it needed to understand more than just nuts and bolts. They needed to understand logic, circuitry, electrical theory, and data flow. And the complexity of the modern systems, it's often said that the modern luxury vehicle contains much more lines of software code than a fighter jet. This is not an exaggeration. A contemporary vehicle is a rolling network of computers, often containing 50 to 100 individual control modules. The modern automobile technician is responsible for a network of systems that are all interconnected. You've got the CAN bus network. Modern cars use a controlled area network, CAN. This is a communication language that allows the various computers in your car to talk to each other without a host computer. The transmission computer needs to know the engine speed. The brake computer needs to know the wheel speed. The climate control needs to know the engine coolant temperature. If a wire in this network is damaged, or if one module goes rogue, it doesn't just stop one part from working, it can take down the whole network. A technician must understand network topology to figure why a radial failure is draining the battery or why a blind spot monitor is preventing the car from starting. And with sensor technology, there are hundreds of sensors on modern vehicles. We have moved far beyond the simple temperature gauges. We are now use LIDAR, radar, ultrasound sensors, seismic knock sensors, wideband oxygen sensors. When these fail, they don't just break physically, they stop sending data, or worse, they send wrong data. A technician has to determine if the sensor is dead, if a wire is broken, if the computer receiving the signal is corrupt, or if the data is simply out of range due to a mechanical issue. So then you have the variable valve timing, VVT, and direct injection. To squeeze more power out of smaller engines while using less fuel, engineers have created incredibly complex internal engine components. Direct injection shoots fuel into the cylinder at thousands of pounds of pressure. Variable valve timing changes when the engine breathes thousands of times per minute. Diagnosing these systems requires understanding of fluid dynamics and precise electronic control that an old school mechanic never had to worry about. And just think about getting into diagnosing based on what I just said. I mean, and think about the education. Think about the technicians of today. They have to be the mechanics of old because it's still a mechanical beast. I mean, it still goes down the road with metal. It's metal making you go down the road, okay? But at the same time, the controls that control that are, think about it this way. It said 50 to 100 different computers without a host computer that are talking to each other. Okay? So, and nowadays, I mean, if you only have 20, 30, 40, onboard computers, and again, this is without a host computer that them talking through, because that was literally slow the process down. So if you had a bunch of trees, and so you had 50 to 100 trees in a grove, and of course the wires and everything are behind the bark of the trees because you don't see your wires. Neither does your technician. They're covered up. They're contained. So they're like behind the bark of a tree. So we pull the code, it gives us a flow chart. The flow chart, then we follow that flow chart and we go to the specific tree and we climb the tree to a branch, sub-branch, twig, leaf. We pull a vacuum on that leaf, or we ohm it out, or we're looking at the waveform from it. We're doing whatever testing procedure we need to do on that sensor or that line. And it says that it's good. It's not saying that it's good forever. It's not saying that it's good in 2 minutes. It's saying that it's good right now. So we have to climb back down that tree, and then we go to our flow chart, and we got to go to a different tree and climb a different tree. And because we have to keep climbing these different trees and going in these different directions, remember, with everything, all of the wiring and all of the vacuum lines and everything behind the bark of a tree. I mean, we can't see them. There's a bunch under your seats, they're in your trunk, they're in your dash like there's no tomorrow, and you can't put your hand up in your dash. I mean, used to, you could reach up into your dash and there was literally it wasn't it wasn't housing very much stuff. Now, you ain't getting your hand up in that dash because it's so full of stuff it defies logic. So now we have to continue to do that, and we finally find it. So we replace one of the leaves, a mass airflow sensor, an oxygen sensor, we fix a connection. We find the problem. Okay. We replace one of your onboard computers. And you drive down the road. The check engine light is off. And 3 months goes by. All of a sudden the check engine light comes on, and you're like, those stupid mechanics. Well, they're technicians, not mechanics, because no mechanic was going to fix that problem that you had with the check engine light to begin with. So then all of a sudden, you drive back in and they're like, well, if it's our problem, it's under warranty. If it's not our problem, which, think about it, there's 50 to 100 onboard computers. There's 3 miles of wire, all hidden behind bark. There's hundreds of sensors. It may be the sensor that they replaced or the connection that they fixed. But what are the odds? And you get mad when the front counter person, the service advisor, tells you that if it's their problem, they'll fix it. But if it's not, you get to pay for diagnosing your vehicle again. You're like, that's wrong. You should fix it no matter what. Okay. Why? There's no reason why. You own it. You bought it. You drive it. You're responsible for it. It's your car. The automotive technician is not your enemy. The automotive repair store is not your enemy. It's legitimate that they want to get paid for any new problem on your car because it's your car. Know that, be that, understand that, and life becomes so much easier, it's not even funny. Stay safe, stay strong.